about like politics is that a lot of decisions can be made using data. And in the modern world, we have access to a lot of new sources of data that we never used to. So maybe think about one of the like themes of this, like of the idea of using data science in politics is what questions, like what political questions can you answer using sources of data? So maybe you try to like type in the chat different ideas of like political questions you can ask about the world and maybe the different sources of data that you can use to answer it. So maybe one easy example is polls or like surveys. So you often see before elections, you see, oh, is this, we haven't actually run the elections, we don't know how popular each candidate is, but we can look at surveys or polling data and see whether or not different politicians are like approved, like the approval rating for different politicians. So maybe like type a couple things in the chat about what you think like different pieces of data, like different questions you can ask about politics using data. Yeah, which people are voting for who. So you can ask using surveys, you can ask to see what people are voting for. Guess you guys need to think about some other ones. Yeah, overall trend of popularity within groups. One you guys probably might remember is actually like for, if you think about social media, you can look at sentiment analysis. So we looked at Yelp reviews to figure out whether people had positive or negative reviews for restaurants. But we also use social media to see, oh, what is the sentiment regarding a certain politician? So is a certain politician popular or not popular based off of whether tweets mentioning them are positive or negative? Another one is economic data. So you can look on whether or not the health of the economy measured like by stocks and unemployment, whether that is correlated with like if you pass a bill, does that improve the economic conditions, or does stock markets influence policy or policy influence stock markets? Another cool piece of data that you can use is geospatial or GIS data. And this is a really interesting example. You can look at like satellite images of hard to reach areas to look at poverty levels, which I thought was pretty cool to see. So machine learning effectively is incredibly good at prediction. So ML has really good predictive power. However, we have to make the distinction between prediction and causal inference. So the question is, what is causal inference? So can anybody type in the chat, what is like causation versus correlation? Yeah, correlation is when two things are related, but causation is when one causes the other. So one thing has an effect on the other. Another, like an example often is when people confuse causation versus correlation. So there's a fun XKCD comic about this, as always. So in this comic, they make a joke about how cancer incidents, so not the cancer cases, rise as cell phone usage rises. So you can make, if you like misunderstood causation and correlation, you can make the argument that cell phones cause cancer. But this guy makes the argument that cancer causes cell phones, because that is like seems to be the data showing that, oh, there is a correlation between rise of cancer and cell phones. But in fact, these things are simply correlated, they're not causal. A lot of political questions are causal questions. So they ask the questions whether something would cause another. For example, what would have been the election outcome if the candidate had not been an incumbent, and an incumbent being they had previously held the office? Another question is, would two countries have fought each other if they had both been autocratic? And then maybe for policy questions, how many more disadvantaged youths would get employed under a new job training program? So whenever you're asking political questions, you're trying to figure out, is maybe the policy that I'm generating, is the action that I'm going to take going to cause the thing that I wanted to cause, or I'm afraid of causing? So that is where a lot of political comes from. You're trying to figure out the causal inference. And this is the fundamental problem. In order to make causal claims, you need a counterfactual. And a simple way to think this is something you probably learned in science class. So in science class, you are taught to do proper experiments. You need a treatment and a control group. If you want to know if chemical X creates reaction Y, you make two different experiments. You make one experiment, which is a treatment, where you use chemical X and then measure whether or not reaction Y happens. And then you make a second experiment when you don't use chemical X and see whether or not reaction Y happens. And if reaction Y only occurs when you use chemical X, then you think, oh, I can make some kind of causal statement that chemical X probably has an influence on reaction Y. And the same thing is needed in any causal claim. So you need to know what happens in the control group. However, maybe, is there a control group in real life? Not really. In politics, you can only observe one outcome for each observation. So there is no second Earth in which doing a different action, you can measure like doing the action or not doing the action. You can only either do it or not do it. You can't do both at the same time. So how do you really solve this problem? So for treated outcomes, you need the outcome had they not been treated, and for control observations, you need the outcome had they been treated. So how can we really implement this in the real world? The solution is matching. So rather than maybe creating a second universe to like measure the effect of your action, what you can do is you can try to match up cases. So for example, if you have the case where I am running a political campaign and I'm trying to make a decision to go on a popular talk show or not go on a popular talk show, and I can either have my politician go on the talk show and see if that hopefully increases their chances of winning, or would the talk show hurt their chances of winning? So I want to figure out, okay, should I go on this talk show? Now I have data from previous people that ran, and I see, okay, did they win or did they not win? And maybe what percentage they win by. So I need to find, using this data, I need to figure out, can I make a decision about whether or not to go on this talk show? So what you can do is you can say, okay, you can find two politicians who are close to each other and find, okay, this politician did go on this talk show and this politician did not go on this talk show, and compare their outcome. And you try to find politicians that are closer together. So for example, you look at what kind of districts did they come from, what kind of office did they run for, the amount of funding they had, the popularity they had while running, all these different features. You match them as close together, and then you compare the distance between the people that did go on the talk show to their matched pairs to the people that did not go on the talk show, and see if there is a effect based off of this one difference in their general like type of person. So you can do the same thing with like U.S. policy. So if you want to know if like a certain policy will have effect on like the U.S. economy, you can match against countries with similar governments and economies. So try to find like countries with similar GDPs and similar governmental structures, and see if policies that did and didn't, countries that did and did not enact these kind of policies, and see if there is a average effect between those two countries. Then you can see, oh, this might mean that the policy will have an impact. So that's how you can do that. Now, another cool thing that you can ask about political questions is predicting election results. This is a huge topic in politics, because it'd be really nice to know if we can predict election results. And this is the project that I worked on. So I asked the question, can economic indicators be used to predict all federal election outcomes? So the data that my group used is we used economic data. So we used unemployment data, S&P inflation data, S&P 500 data, monthly recession indicators. And then we also looked at the election data. So presidential election races, Senate and House majority, and local Senate and House election data. So this is what the data looks like for the stock market versus the election results. So the black line is the stock market, and the orange being the highlighted recession indicators, and then different colors indicating controlling parties in the House, Senate, and presidency. And here, if you look at the data slightly, you can sort of see dips in sort of like recessions are correlated with changes in parties. So this might mean that we can use recession indicators to predict party changes. And then we can here also look at the unemployment data. So this is unemployment data graphed against like whether or not a party changed. So the red line shows that the party did change. So the person like it switched from Republican into Democrat. And the green line shows that what is the average unemployment data that the party did not change. So on the graph on the left, you can sort of see that a party change is correlated with an increase in unemployment data, and no party change is associated with a decrease in unemployment. Whereas for incumbent presidents, incumbent meaning so like the same person who held office is running again. So for example, Trump was the incumbent candidate in the last election because he previously held office. In 2016, neither candidate was the incumbent candidate. And here you see that the average unemployment is sort of like flat for incumbents winning, and the increase in unemployment is much higher when they lose. And this you can sort of has a couple different, could assign a couple different explanations, but it might mean that it takes a larger rise in unemployment for an incumbent to lose. And the method we used for creating our models was we tried support vector machines, random forest, and gradient boosting. And we also did threefold cross-validation on our data. So you guys have done some splitting of your data sets where you take 20% of your data to hold off to the side in order for your validation sets. What threefold cross-validation data does is it splits your data into 3 sets, uses 2/3 of it for training, and then keeps 1/3 to the side, but then changes which third it keeps to the side every time. And this prevents errors in accuracy analysis that might come from picking random amounts of data for your test set. So this is our results when we looked with and without unemployment data. So even with and without unemployment data, our gradient boosting algorithm was able to, with 100% accuracy, predict presidential incumbency losses. Okay, my screen's glitching a touch. Yeah, we also looked at short-term and long-term indicators. So short-term indicators being just economic data from just before the election versus long-term analysis indicators being the change in the economy over a longer period of time before the election. And we found that long-term features gave us much higher accuracy than short-term features. And this also, we can also look at feature importance. So once we create a model, we can also see, okay, which pieces of data or which features of our data are the most important in making the decision in our final outcome. So effectively, which inputs are weighted the highest according to our algorithm. And we found that very long term, so 36-month, 24-month data is the most important data when making a prediction as to whether or not a candidate would win. And then we can also track the accuracy using data up until 18, 12, 6, and 1 month before the election. And we found that even using data only up until 6 months before the election, we were able to get 100% accuracy. So the question that we asked was, will Trump lose the 2020 election? You guys probably know the answer by now, but our model predicted that yes, Trump would lose the election, and we can tell 6 months before the election that he would lose. So, which is that was pretty cool to see, because we actually created this model like just before the election. Fun to see. However, as always, it is very important to know that machine learning is not causal inference, so we can't make any causal claims. So we have, these are all the different findings that we were able to find. So we were able to predict incumbent losses very well as presidential party change moderately well. But we could not predict election results in the House or Senate. And then we were also able to predict different election results. However, the most important thing is that, again, machine learning is not causal inference, and 2020 is actually a great example. So even after predicting Trump would lose, we would need to do further analysis with counterfactuals in order to ascertain whether sort of a similar economic pattern or economic crash which happened before the election without the pandemic would have correctly predicted the 2020 election. So for example, we might look at, oh, I was able to use the economic data to predict the president's loss. However, it might not have been the economic state of the economic state of the U.S. that caused Trump to lose the election. It might have been the pandemic that caused him to lose the election, but the pandemic also affecting the economy. So this means that we can find that, the most important thing to know that when answering these kind of questions, what we can do is we can find, oh, is this a good predictor? So are these data points good predictors at answering the question? So good predictors as figuring out whether something will lose. But with machine learning, you have to be careful that you cannot make claims that, oh, this definitely causes something else, because otherwise you'll run into the issues of correlation versus causation.